Welcome to the Better Buildings, Better Society podcast. Twice a month, we interview interesting individuals and get insight into what they think makes buildings better members of society. Subscribe to our podcast and share with your friends. Hi, I'm Stephen Forster, founder and principal of DMA Engineering. My passion lies in the built environment and in the mechanical systems that keep buildings running at their optimum efficiency, while at the same time provide the best possible health and comfort to their occupants. In this way, DMA is absolutely committed to making buildings better members of society. This podcast focuses on energy efficiency through the eyes and experience of building industry professionals. Together with my guest, I will lead all of us on an exploration of how to build better energy efficiency buildings, how to save our clients time and money, and offer practical advice for those interested in the built environment. Join me, a mechanical engineer, outdoor enthusiast, and green advocate as I interview guests with leading edge ideas for creating better buildings and a better society.
Hello again. I'm Stephen Forster, principal engineer of DMA Engineering. Thanks for joining us for episode 13 of Better Buildings, Better Society. This week we have Peter Ewers, licensed architect for over 31 years and founder of Ewers Architecture in Denver, Colorado. Actually, that's Golden, Colorado, right? So
it is.
Peter's passions are exciting architecture, environmental sustainability, respecting historic buildings, and using architecture to help people. He has advocated for sustainable design through numerous speaking engagements at venues including the World Renewable Energy Forum and AIA 2030 Challenge classes, among others. We are excited to be hosting Peter and thrilled to explore more about sustainable architecture can make buildings better members of society. With that, it is our privilege to welcome Peter to the show and learn more about what inspires him in this industry. So, how you doing today, Peter?
Great. Thanks for having me on the show, Stephen. I really appreciate it.
I really appreciate you joining. You and I had lunch a couple weeks ago, and it was a really good conversation towards the end. So, just think, see if we can just kind of further that conversation as we go through this. So, yeah, it's pretty good.
Thanks.
So,
I would note that my last name is pronounced Ewers. It's like it's EWE. So I tell people it's like a female sheep, like a U with an RS on the end.
Oh, so
Maybe
Ewers.
that helps people remember Ewers.
Ewers. I'm sorry. I apologize. You should clarify that.
That's good. Hey, you got it pretty close.
Cool, man. All right. Well, so give us a little background and about your firm and how you got designing and what brought you to architecture.
Mm-hmm. Oh, gosh, that's a lot of questions right there. Well, I've had my own firm since 1997, so it's been pretty close to 25 years now. Right here in Golden, my office is 3 blocks from my house, so I can walk to and from work. And that was always a life goal of mine, is to have my own small firm in a small town close to a big city. And Golden really fulfills all that. We're close enough to Denver that we really get to capture a lot of the excitement and the architecture that goes on in Denver. But being just out in a small town where you can wander down the street and you know everybody. And so we have a small firm here. There are 5 of us, and that's also by design. I don't really want a large firm. I like architecture, and I want to do architecture. So having a small firm allows me to be really intimately involved in every project and really get to know the clients and their desires. What got me into architecture? That was a long time ago now. And before I started college, my dad suggested I might think about architecture because it's a nice blend of art and computers and mathematics, and so kind of that right brain and left brain blending, and that suits me pretty well. And so here I am, 30 years later.
Well, that's good.
40 years later.
Yeah. Was there anything that your dad kind of, when he suggested that, do you think you had a natural affinity for both math, science, and art? Were you already working around in that world, or was it just something that you just seemed naturally curious to be in?
Yeah, I don't think I gave it a lot of thought. I think my dad suggested, it's like, oh, that sounds cool. An architect. Well, yeah. And then I got into it, and 5 years of school later almost beat it all out of me. By the time I finished school, I was. I actually told my dad, I said, I don't know if I'm really going to be an architect. I'll go work in architecture for a few years. But I was so burnt out after 5 years of school and lack of sleep, and that. But when I got into actual fields of architecture, I realized it's a little different, not quite like school, and I really like it and have really enjoy it. So after a couple of years, I told my dad, I guess I'm here to stay.
Well, that's good, right? I mean, what we learn in school sometimes and what you actually get out there and use in the real world is a lot different, right? And then the actual practice is different, right? So, yeah.
Mm-hmm. Yeah. But school is so important because that's where we learn some of those real deep-seated, how to make beauty out of things and how to make organization out of chaos. And it's where we really get to spend just an insane amount of design hours to try to find a good solution to a project, which you never get that much time in the real world. So good thing I had 5 years of that, so that when I got in the real world, I could hone those and do it faster.
Right, exactly. If you're trying to do that in the real world and hone those skills, A, either you wouldn't be making any money, or B, the client would be getting a big bill if you're billing out hourly, right?
Yeah.
You would never get another project.
Never.
Yeah. So what's the biggest challenge facing architects right now?
I would have to go with construction cost is a real a huge issue for us right now. That we are the costs have gone up so fast, and they're just extraordinary that it's limiting who can build what. It's limiting what we can do on our projects. We're starting up design on a school addition right now where they really can only afford to build about half of what they really need. And they thought they would have enough money, but they just don't. And it's really putting a lot of pressure on that. And then the supply chain issues and just construction has changed so much in the last few years that I think that's one big thing. And then sustainability is something that I love and I love to work on. And it's something that is really, really coming to a forefront now. We have to do better in order to have any chance of turning the climate change around.
Yeah, for sure. So let's just think a little bit further about, what do we think in 3, 5, 10 years? Immediately, I think sustainability, right, in the next 3 to 5 years has definitely got to be a big thing, and be making those building practices, right? Because the industry has to kind of evolve a little bit further to be able to do more sustainable design, right? It's a little bit different to do continuous exterior insulation. So I think there's a big hurdle there. So I think, 3, 5 years, maybe it's all sustainability and tradespeople being more technicians, if you will. I mean, they're craftsmen now, but taking that to another bit further level, maybe they're technicians. And then 10 years, who knows what we're going to be seeing in 10 years.
Yeah, it's amazing. We know what to do now. We know how to do it. We can make buildings all electric and net zero energy. What is the holdup is just the doing it and educating our clients and contractors and even jurisdictions for building departments, planning departments, and getting everyone on board. And but we can do this. We have all the technology that we need now. And you're seeing some places that are doing things like eliminating natural gas from new buildings, not allowing any new natural gas connections. And that's got to become more and more standard. And at the same time, we have to plan for that extra electricity usage, and we need more sustainable electricity. Is really, that they fit very, very well together. We're learning how to build buildings using all electric systems. And then we are also making our electric grid more and more sustainable. And we're not building any more coal burning power plants. We're only and we're building very, very few natural gas power plants. Almost all of the new electric power coming on board in the United States is either wind generated or solar generated. And all of that working together, I think it's going to be a really exciting next 3 to 5 to 10 years as we watch the tide turn. And I'm an optimist, so I believe we're getting there, and that we can get there together. But education, making sure that we get everybody on board and don't leave anyone behind. That's key.
Yeah, for sure. It's definitely the education piece all the way around of, it's like you said, we have the technology to do it. We know how to do it. It's just making sure that everybody understands that it's nothing new, right? We're not reinventing things. We're not building these crazy prototypes to make all this happen. It's like, it just needs to become more ubiquitous and people just able to do it, right? And having the tradespeople understand how to do it and what's important, right? Air sealing now, infiltration is a big theme, right? That's the big way to knock down a lot of energy, is just having a tighter building envelope. So just even though understanding those details and the staging of how those systems go together we're in the infancy, if you will, of just teaching people how to do all that stuff, right?
Yeah.
So what do most people misunderstand about designing and architecture?
I think it varies by the person, but some people just don't know why they even need an architect. Sure, I need a structural engineer, but why do I need an architect? But the ones who know that they need an architect, it's still getting people to understand that we are really, truly, we're problem solvers. That's what we're doing. We're identifying problems and finding solutions to them that other people might not think about, and asking people to rely on us for that, asking them to rely on us for those solutions, and to present a variety of solutions. We're often battling a client who they so badly want to draw it themselves. And, but we tell them, no, if you can put into words what the problem is and what you want to solve, then we can offer, that gives us so much more flexibility to offer unique solutions. But if you just say, here's what I want a bedroom here, my living room here, and my kitchen here, and this is perfect just like this. And if we don't understand what they're really looking for, then we can't problem solve. We have to understand the problem that they're trying to solve. In life, if anybody presents you a solution to something and you say, well, okay, that's got to be the solution, because they haven't presented you a problem, they've only presented you a solution. And that's what happens when our clients or whomever draw for us. They're showing us the solution. Sometimes we can read between the lines and find the problem in there and find other ways of solving it. But really, if you're presented a solution, then it negates the opportunity to come up with a really unique way of solving a problem.
Right. That's what we do as engineers and architects. We solve problems related to buildings. So yeah, that's exactly it.
Yeah. If someone came to you, Stephen, and said, this is the exact mechanical system I want, kind of all you can say is, all right, I'll just fine tune that mechanical system for you. But if they come and they say, I just want the building to be comfortable, and here's what I really like. I hate air blowing on me, and you could come up with a bunch of different solutions that could solve that. But if they come to you and say, this is the answer already, it sort of limits you.
Yeah, it does. And we can't, and I don't think we're able to do our best work, right? I mean, that's the one thing is it's like we're not able, because we don't understand what they're trying to get to. And maybe they've already gone through something and they've said, this is the cheapest solution and this is the one I want, but they've forgot about different other things. And you're just like, well, what about this? What about that? And they're like, no, this is the cheapest, this is what I want. If that's what they're caring about, it's just first cost. So yeah, you do have to watch that. And there's always the code stuff that needs to fall into making it all work, right? Well, especially if they come to you with a natural gas furnace, and you're like, well, you can't do that anymore. It's got to be all electric. And they're like, oh, well,
yeah.
So yeah, it's all that stuff that happens. So yeah.
Yeah.
So you've been recognized in numerous awards for solar and sustainable homes. Can you speak a bit about that in sustainable building practices, and I guess just a little bit about what those awards mean to you, and yeah, what does that all mean as far as being a good steward for the industry?
Yeah, I love doing things like this. I'm honored that you'd asked me to speak on your podcast. I love it when we're asked to be part of the solar the tour of solar homes in the Denver area. We always have a few homes on that tour. Whenever we win a competition to design a building, all of those things. Anytime we're recognized is nice, but it's it's validation for that we're at least on the right track. We're designing a Buddhist center right now in downtown Denver, and we just got the city of Denver just awarded a grant to the building to ensure that it is all electric. Net zero energy is the goal, and then they want to hold that. City of Denver wants to hold that out as a poster child for this is what you can do, and you don't have to use natural gas, and you can heat and cool a building, even a building that has a meeting space for 300 people. You can provide all of that, all of the needs with electricity. So I love speaking at conferences and just getting that word out there to help other people know what to do and that it is possible and that we have all the tools that we need. So I enjoy giving back in any way we can to help further what we're all trying to do, build better and more energy efficient and more comfortable too. And that's something we sometimes forget. Energy efficient buildings are typically more comfortable, quieter, lots of other side benefits.
Well, yeah, and I think those side benefits are obviously, they're really not side benefits, right? Because the buildings are meant to occupy people, and a building that is can serve its occupants, and right, it's more comfortable and it's quieter. Well, who doesn't want that, right? I mean, that just should be. Yeah. That's what people should be demanding from their buildings. Is just to begin with, it needs to be comfortable and it needs to be quiet. Because what I do in my space is what I want to do in my space, and it shouldn't be a side benefit of doing good design. It should just be. It should be the norm, right? You mean I get, and it shouldn't be like, oh, I get that. No, all right, I'm getting that. It's very, it's just, I think people have come to accept certain things within buildings, right? And they just kind of understand that's the way it is. I mean, I think air conditioning came out in cars before it ever came out in homes, right? And as soon as it was in cars and people had it in their cars, boy, they sure wanted it in their houses. And they didn't, it wasn't ever thought of, let's put it in houses. It was put in the car to make the first way it came about. So it's a interesting way that things happen, right? It was a side benefit over here of a car that they figured out how to make it happen. Now everybody wanted it in their homes. And their homes were leaky and drafty and all that other stuff and energy inefficient back then anyways. Oh. But I guess speaking at conferences, what's the one, what's a common theme you hear from just people at the conferences, afterwards, you always, what's the one question you hear a lot of? You're just like, yeah, it's still, when you're talking about electric heating and all these, and sustainable design and, how much it actually doesn't really cost a whole lot more when you look at pricing holistically on how to do a more sustainable design. What's the common theme that you kind of hear?
I'd say what I hear most is people asking, how did you convince your client to do that? How did you get them to? Because I'm typically talking to other designers, whether it's engineers or architects, and they have similar projects, but the owner just wouldn't sign on for going to that level of sustainability, and a couple different answers. One is, it is what we do. So a lot of times our clients are finding us because of that. So we're kind of starting with a stacked deck already. But the other thing is that, honestly, just some people may not want to hear this. We don't ask anymore. We don't ask our clients, oh, do you want really high levels of insulation? Because then the question that always comes back is, well, how much is it going to cost me? And instead, we just put it on the drawings. We don't ask. We just say, this is what we're doing. And this is why we're doing it. And they're like, okay. And then the question comes when the contractor gets a hold of the drawings, and the contractor calls up and says, we don't need that much insulation. Code doesn't require that. Or we don't need, whatever it is that we put in. We do a lot of double stud wall construction or continuous exterior rigid insulation, either or, but making sure that is continuous. And no, code doesn't require it, but we do. And but often the contractors, and sometimes every once in a while a contractor wins. they convince the owner that they can save so much money they should do it differently. But most of the time. So yeah, after speaking, people come up to me and they just wish that they could convince the client, and hopefully, maybe some of the things that we showed them will help convince the client. And but finding multiple benefits, like we were just talking about, is really good. On this Buddhist center, it's right on Spear Boulevard, so it's very loud, and we've had a sound study done of how loud the traffic is, and we've got this big meeting room right on the other side of the glass. And so we also have a great energy modeler on the project. The energy modeler is saying, double pane windows are okay. It'd be great to have triple pane, but double pane will be fine. We can work with that. And we're saying, no, we need the triple pane for the sound barrier from all the traffic on Spear Boulevard coming into that meeting room. And that's what's really going to convince the client. If we tell the client, look, you're going to save, you're going to spend an extra $30,000 on windows, and you're going to save energy-wise, it's going to save you $200 a year. They're going to say, I don't want that. But when we tell them that it's also going to make the room quieter, you're not going to hear the traffic out on Spear Boulevard, then show me where I sign that check. That's I have that. So
yeah, for sure. And I think, just even like the window conversation, we just recently went through a life cycle cost analysis and trade-off analysis on a project, and we were looking at the windows. And back in 2015, we did a thing on windows, and to go to like a triple pane high performing window, it's like a 2x on the cost of the windows, and now it's 10% more for the cost of the windows. It's like some stuff that we used to think, and that was 7 years ago, was like cutting edge, right? Bleeding edge, triple pane, high performing windows with the U value of 0.19 and a solar heat gain coefficient of 0.19 was cutting edge. And now you're just like, yeah, it's 10% more. Why would you not do it? Right. It's not even worth talking about. It's just, we just do it. Right. It's like, the only thing is the solar heat gain coefficient may have a tint to the window that can not be architecturally pleasing. But it's just like some of this stuff now that we used to think was really cutting edge and there was a lot of costs associated with it is no longer there. It's just prevalent in the industry. The industry's evolved far enough that we don't have to do that stuff. So yeah, I think it's pretty interesting. And then like you're saying, just to say the sound is the other side of it, right? The sound is going to make the question. So that's exactly why they're going to, they have to go that way, because otherwise they're going to have a noisy room. You're going to have a big, large truck go by. It's going to get quiet in the room, and you're going to hear that truck go by, and you're like, that's not acceptable.
Lovely thing. Yeah. We just put them in an office building here in Golden. And as the contractor was putting them in, he said, oh my gosh, such a difference. He said, as soon as we put that window in, it just cut out all the sound from the street. He said it was amazing. They put in windows all the time, everywhere. But this window is special. That triple pane just really, really did it. And they're a little bit more than 10% more when you're talking commercial, when you have to go from a storefront system
right.
to a curtain wall system in order to get the triple pane. And it really but in residential style windows, yeah, it's not as nearly as big of an ad.
Yeah, exactly. And I guess this is a question I ask a lot of architects in the commercial world about things. It's like curtain wall versus and curtain wall, I forgot now. Help me out. What's it there? You got curtain wall and
storefront,
mm-hmm. right? Mm-hmm. So, the building envelope council is almost saying like we shouldn't be doing storefront, it should all be curtain wall, right? I mean, just because it's so well the thermal break is so much greater with a curtain wall than storefront that we shouldn't be doing really storefront. Would you agree with that, or?
I think there are some good storefront systems out there. It's just that there are more options in the curtain wall systems, and they have water management built into the frame, so you can't get storefront windows taller than 10 feet tall. If your window needs to be higher than 10 feet, then you've got to go to curtain wall. But there's some good. I would say there are some good storefront. I mean, the thermally broken technology, so you don't have this solid aluminum going through your building, and that thermal break that they've developed over. It's been, gosh, I don't know when it came out. At least 30 years ago. But 30 years ago, it was, I don't know what they were using for the thermal break, but that thermal break has gotten so much better and better and better and better. And I would be okay using a storefront window as long as it had a really good thermal break and good, as good of a double pane insulation or insulated glass that we could get. You're still going to get, 0.28 or something like that out of the window. But if you want to get down to 0.20, 0.19, like you said, then it's got to be curtain wall. And it's a big difference from 0.28 to 0.19. That's then you're talking comfort next to the window as well, because 0.28 is like an R4 or R3, 3 point something, and the 0.19 is an R5. So you think, oh, that's not that much difference. R3 to R5. That's what
50%,
66. Yeah. I mean, it's 67% better.
Yeah.
I mean, it is a huge change. Yeah, if you go from an R wall that's R28 to R30, you go up two levels in the R value. When you're up at that, it's not going to be much of a difference. But when you go from R3 to R5, that's a big difference. And that's noticeable when you're sitting next to the window, whether you're in a class or in an office, you're sitting next to that window. And when it's 0 degrees outside, the heat from your body is just going to be jumping over to that window. That radiant heat is just, you're just going to feel that coldness from the window. And if you get that, but you get a better, well-sealed, well-insulated window, the comfort level is so much better. And there's a huge value in that. And people are more productive. They're happier.
Well, and they want to hang out in the space longer, right? I mean, I mean, that's the other thing. I mean, you just want to hang out in the space longer, and it just, that's what you want to do in a building, right? I mean, you want to be able to hang out in that space longer and just feel more comfortable. Couldn't agree more on all those. So what do you wish you'd known when you first started in this industry?
Wow. That's a tough one. That was a long time ago. When I first started, I didn't really know very much. So I've learned a lot since then. But architects have a lot of influence, and I don't think I really got that. I don't think I really understood that until I had been worked for a couple of decades and realized, wow, we really wield a lot of power, and we need to be careful with that power. We need to be very thoughtful and diligent in what we design and draw and suggest. I wish I'd have known that, right off the bat, that someone has said, you're even you just fresh out of school, you're starting to draw some things. There's power in those drawings, and you're influencing people's lives and how they're going to live and how they're going to work. And that's something not to be taken lightly. And we really need to think about those lines that we put down on paper, or the virtual lines we put down on our computer screen, and how they affect people.
When you think about the influence, there's a lot of different ways buildings influence. Cities, everything, right? There's certain cities just have very iconic buildings, and you remember the city because of the building, right? Barcelona. People talk about the architecture in Barcelona, right? There's a city that people just remember for a lot of the architecture, and there's multiple cities like that. And so I think when you think of that, the power that they influence, what's the biggest part of that influence that is there? Is it just a building that can be iconic, or is it just whether it fits a neighborhood? What do you think that influence is?
That's a good question. I have a little story from early in my career when I was just told by my boss to draw this elevation, and the building had a couple little businesses in it, and a coffee shop and a daycare. It was in an office park, and so I drew it, and I was having fun, and so I made cute little names and logos for each of the businesses that I was pretending were in this building. And it was maybe a year later, I'm driving down the street, and I drive past the building, and I look over, and there are the exact names and logos that I drew on this elevation one afternoon. It's just, I think architects have the power to put down ideas, and those ideas affect people. And sometimes they will just take that and say, well, this is what the architect said to do, so let's do it. And so that's kind of what I was getting at with the influence and power. But we do, how we design has great influence. When we design a house, and we design it so that the living area inside opens beautifully to this outdoor living area, we're influencing how that family can live their lives, and how anyone who lives in that house can have the enjoyment of indoor-outdoor living. And if we don't do that, because I've been in some beautiful houses that have a wonderful living room, and you're standing in that living room, and you can look out to this beautiful backyard. And to get there, all you have to do is walk through the kitchen and through that side door and out and down some stairs and your yard. Well, that influences how that family is going to live. They're not going to be living indoor, outdoor. It's a chore. Going outside has to be a very specific thing that's what you want to do, rather than just having the space that beautifully opens up and invites the outside in. Those kinds of decisions are things that we do and things that we draw, and our clients may not think about. Some of them do, but a lot of them don't. A lot of them do. They'll build what we design. And
I just love that story about the logos, right? You were just like, all right. I mean, I just love that. That's just great, right? I mean, you're just like, yeah, I'm just going to give this little artistic thing right here. Boom, put it in here. That's what I think would be a cool logo. And then you drive by a year later, and you're like, hey, they actually use.
You'd have blown me over with a feather when I looked over. I was like, what? That's the elevation I drew.
That had to make you laugh. Yeah,
it did. But it was a good lesson to learn.
Yeah, for sure.
Yeah.
One of the things had this book. I can't remember. Kelly Scott or Kelly somebody or other, the guy that designed the Blackbird, the SR-71 Blackbird, right? So one of his first stories that he wrote in his autobiography was he drew a drawing with it, and they were making a new oven, and so he goes down to see how they're producing on this oven, and it was a masonry oven that they were building from scratch to make something, and the guys were cutting the bricks. And he's like, why are you guys cutting the bricks? And they go, because you put on the drawing that it needed to be this size. And you called the brick this, bricks are nominal size, but they were actually cutting him to his size. And he goes, oh, no, that's not what I meant. And he goes, right then and there, I learned the power of what I put on a drawing has to make sure it makes sense, because somebody may actually take that and make it what it is. And so you draw the logos, it's kind of the same thing. You're like, oh, okay, there we win. It's kind of, it's comical now, but everybody liked the logos. But yeah, exactly.
Yep.
How that can happen. So yeah, you're right. The lines on the drawing are powerful. And we need to realize that, especially in the day of computing, we can do so much in BIM, right? We can draw so fast in BIM, and the drawings have a certain look to them just because of the way the BIM standard is and how things look. The drawings have lost a little bit of that artistic aspect of them, if you will, right? They're a little bit more mechanical when you look at a set of drawings, where before, even with AutoCAD, there was always a little bit of how much you offset a line and all those there's a little bit of artistic value in the drawing that was actually kind of how you interfaced with that drawing said something, right? I mean, we lose that a little bit when we get into the BIM world. For me, I mean, sometimes you look at a BIM drawing, it's very mechanical, and you're like, all right, it's all the information's there, and it's not presented the best way, but it's presented. So I find that with BIM that sometimes when I look at the BIM drawings, I'm like, yeah, these drawings just don't have any character to them, right? It just feels very mechanical. So that's one aspect I see in the industry that's happening. That is just like, the lines you are putting on a drawing, how are those going to be represented, and what's that first interaction with them? I think is very important as well.
Yeah.
It's interesting. So what are you currently researching or has struck your curiosity?
Well, we're certainly working hard on net zero energy and all electric buildings. That's just that's a given. I don't know that is so much of a new thing anymore. It's become more and more commonplace, though we still see so many examples of it not being done. But we certainly hold that out there, and that's something that we're very, very passionate about. And we talk to our clients before we're hired and said, this is how we're going to do the building, and make sure that they're on board with that. And we have turned away some clients because we just say, they're not ready for cutting the ties to natural gas, and we just don't want that in buildings that we're working on, because every building is a little bit of a laboratory. Every building is an experiment. And if we're working on a building that does something that we don't really want to do, then we're taking, usually hundreds of hours of our time, and we're experimenting with something that we don't even want to experiment with. So we'll only take on those projects, those experiments that allow us to continue working on. It's interesting. So we're using, a few years ago, we had this crutch that we'd use, and I call the crutch the ground source heat pump. Ground source heat pump is an awesome system, and I know you know it well, Stephen. But so this ground source heat pump, they're very expensive, and they provide heating and cooling to a building just about anywhere. You don't have to think about it so much. I mean, the systems work. And so in these last 5 to 10 years, we've really been playing more and more with the air source heat pump systems. Much less expensive. You don't have to drill these 300-foot holes into the ground. They just work just like an air conditioner has worked for decades on houses. We just run them forward for air conditioning and backwards for heating. But they only work when it's warm enough outside to actually be able to capture some heating out of that. And fortunately, that temperature that they'll work at is getting lower and lower, and now we're all the way down to like negative 17 degrees, and they'll still produce some heat. But we also do a lot of work up in the mountains here in Colorado, and when you get up at 10,000 feet, you get some pretty cold days. And so how can we use air source heat pump technology in those kinds of environments? And what's an efficient way to do that? And so in the more extreme environments, I think we've got it dialed in, how you do air source heat pumps, whether that's for a residence or whether on commercial projects, we're using VRFs, and residential systems use a little simpler version of that for their air source heat pump, mini split. You hear a lot of people call them, but pushing that technology along to use in more extreme environments. Or what I'd love is an air source heat pump system that can be used for radiant heating and cooling. Maybe radiant floor would be great, but radiant heating and cooling, because the radiant systems are so nice. You're not pushing air around. You don't have the air noise. Just really quiet system, especially for a residence, but even for small commercial applications. So playing with that, the technology that has come about already and is coming about is really exciting. It's a fun time to be doing what we're doing and to be trying to save energy and do things with all electricity. We can do that. We can do things now that we just couldn't do 10 years ago, or certainly 20 years ago. And so seeing that all integrate with combating climate change is really, there's some beauty in that, how it's all coming together.
Yeah, and I think, just echoing on that, right? I mean, the air source heat pump system technology, like you said, it used to be 47 degrees. You start losing a lot of COP, right? And you know what I mean? That was the old.
That's longer ago. I remember 30 degrees. I don't remember 47. I remember below 30, it was a tough sell.
AHR rating is 47, and then it was 23 degrees F that they would stop operating. That's what it was.
Mm-hmm.
And now you're right. I mean, we're down to negative 17, and you're getting like 80 to 90% of the capacity out of the unit. And those numbers have changed within the last 5 years, right? That technology is just increasing super fast. And the whole thing about it is, it's like combustion technology with the gas-fired furnace or boiler. They're at 95%. They can't get any more out of it. That's it. I mean, they've hit that limit. They'll never be able to get any more out of it, because I mean, that's all that's there.
So that's 0.95 efficient. Rather than these air source heat pumps, are 3.4, COP, the coefficient of performance over 3. So for every unit of energy that you put in, you're getting 3 units of heating and cooling out, rather than 0.95.
Exactly.
So it's awesome.
And that technology has a lot more room to grow. I mean, that's the whole thing.
Think it has a lot more?
Oh, I think it has a lot more room to grow.
Yeah, great. I'm glad to hear that.
I totally think we can start. Well, at some point we'll see COPs of 5 being just common. I mean, I just think there's a lot more to do with the physics, the chemistry of the refrigerants, right? Propane, ammonia, even refrigerants that haven't been designed yet, that can be figured out. Nanotechnologies can help those type of things. I think there's a lot more to go. The inverter-driven technology, right, just of the compressor themselves, where you're always continuously load matching, right? So you're making sure the supply air is always optimized. So you get rid of those peaks and valleys. It's not an on and off system anymore. You kind of always have a fan on or a motor on, just always meeting that occupant comfort, right? You're always staying within a degree of where it needs to be, because you can just you can modulate the systems, right? So I agree that technology has a long way to go. I think along with that, right? And you called it a crutch with the GHSPs, and I think there's somewhat of a crutch with the GHSPs, the ground source heat pump systems, was just a bad building envelope. And I think, you could say, well, yeah, we want to hit net zero. We're going to use a ground source heat pump system because we have a bad building envelope, right? And whatever. The economics always pans out that insulation in windows is cheaper than mechanical systems. And then you get the side benefits, which we talked about before, which was a more comfortable building. You can put extra, in our trade-off analysis, we put weighting factors on those things. And we say, hey, this is, the weight of what it is. We're going to weight the occupant comfort is higher than maybe the architectural impacts of going to a double stud wall. So it's just those type of things that, people, I think when you look at it from a weighting factor, we used to call it externalities, right? And I think externalities got to be such a nasty word at some point, but it's not really a nasty word. It's like, you got to look at everything holistically. I mean, that's the whole thing about sustainable design. You have to be looking holistically or you're going to miss stuff. And I think that's where things, I think, and the biggest things have changed in industry is just that holistic approach has become more, we just do it on every project. Like you say, we just tell our client, we're going to put in 1 inch of exterior insulation. We're going with double stud wall, right? I mean, I think that's brave. But I also think it's kind of the right thing to do, just to say, if you want to work with this is kind of what we're going to do.
Yeah, if they hired us, they want a good building, and so we're not going to talk about how we can build them a crappy building. We're going to just provide them a good building.
Right, yeah. So I mean, what we've kind of already hit a lot of this stuff, but it's like, what direction would you like to see architecture as a whole take in the next few years? I know we talked about the net zero, but above and beyond that, what do you think? There's the 2030 challenges. There's all those other things out there.
Yeah, and those are doing great. The LEED program and all of that are just doing really, really good stuff. It's got to, I feel like it's the top 10 or 20% of our professions, whether that's architecture or engineering or construction, that are hitting the mark on all that. So we got to flip that, and we've got to make this for more and more of the masses. And codes are our friend, because they're demanding some of these things that we used to have to convince our clients of. Now it's whether the city you're designing in won't allow a natural gas connection, so you just have to do this, or whether it's they're demanding, they have the code, maybe they're demanding you to meet zero code, or there are a lot of things coming about. But I think that we just need this to be more normal than it is, and I'm very happy with where we've come to already. But there's still a long way to go, because I see a lot of people not doing it. I spoke to a new mechanical engineer that we were talking to that we hadn't worked with before, and asked them, how many of your projects would you say you're really pushing sustainability? And they said almost zero of them. So until a fairly large firm like that says almost all of them, then we're not doing our job yet. We need to help the entire industry along, and not just rest on, well, we're doing it. It's got to be everyone doing it. So what can we do? How can you and I work together and make sure that others are doing it? It's great to speak at conferences, but who shows up at conferences are the people that want to do it, and the people that are really working at it. And but there are a lot of people out there doing lower quality construction that we need to get on board. And I think that's a challenge for our industry.
So right, being kind of on the cutting edge of taking on a sustainable design, and understanding that, net zero, been doing net zero for over 10 years now, right? It's like everybody's talking about net zero, but it's like, hey, thanks for catching up, right, a little bit. Right? So what led you to get into the sustainable world, and what was your motivation for being one of the ones that say, yeah, we got to do better? What drove you to get into it? And where did what drives your passion for the sustainable world, to go out there and speak and all that?
I'm not sure I really have a good answer for you, Steve. It's always been a part of who I am. I mean, my family was in the 70s, we were doing recycling, and we'd go down and volunteer at the recycling plant and separate the green bottles from the brown bottles and the clear bottles. And I remember caring deeply in the 70s about pollution and trash. I'd like to go around our neighborhood and just pick up trash. And I've always, it's just been a part of who I am, I guess. And so translating that into, after getting some education, working, and deciding that, hey, I don't want to build buildings that are part of the problem. I want to build buildings that are part of the solution. And then I enjoy helping anyone, but speaking at conferences, putting out any information I can, is enjoyable to me. I like doing this, and yeah, I have lots of stuff I could be doing right now. Lots of projects that need some attention, but this is important to get that word out. And I don't know how many people will hear our conversation, but the people that do, hopefully, it encourages them to do the same and to make a difference wherever we can.
Yeah, and I mean that's totally the holistic view that we have, and that's why the podcast is Better Members, Better Society, or building better buildings, better society. Right? What can we do to have an impact? And we've chosen to be in the building industry, right? But that doesn't mean that we just keep doing business as usual. It's like, what can we actually do to make sure that buildings don't have the impact that they have, right? I mean, we're building, like you said, you have an influence in what you're building. It's going to be there for a good building should be there for at least 50 years, 100 years. Let's hope 100
That's
years.
the hope. Yeah.
Yeah. Right. So,
let us imagine that we build forever. Yeah.
Yeah, exactly. So I kind of just a technical question. So what's your favorite wall assembly? Is it double stud or is it continuous insulation? What's your go-to? Double stud?
Well, on one house, we did them both. We did double stud, and then we did an exterior rigid insulation. That was, R40 plus walls. I think my favorite exterior wall insulation would be something different. We do a lot of double stud wall construction. We do a lot of 2x6 with blown fiberglass insulation, the blown-in blanket system, and then an exterior, 1.5 inches of rigid insulation, and it makes a good wall. But I like a SIP panels for walls, structural insulated panels. They're thin and they're really well insulated, and they go up quickly. And I also like ICFs for exterior wall. We've done insulated concrete forms. We've done straw bale. I like experimenting with different things. So something that we haven't done before would be fun. I've never gotten to do a cob wall or earth rammed earth. Those would be fun to experiment with. I do like when you talk about ICFs, insulated concrete forms. There are a couple of companies that are doing, well, there's the Rostra panels and then there's, oh gosh, I'm going to forget the name. There are a couple of companies up north that make a block.
Aerated concrete blocks?
Yeah, they're no, not aerated. We have looked at those, and that would be an interesting typology to play with as well. But it's still an insulated concrete form, but they don't use any polystyrene, which I think is really cool. So they use just like a concrete and wood slurry to make the block, like the big Lego, and they're heavy. And then they use a rock wool insulation inside to build the wall up, and those are great walls. So any of them, as long as we get that continuous insulation out, no matter how you do it, it's just not okay anymore to just build a stud wall and put insulation in between the studs and call it good, because that's not good.
Then why do you say it's not good? Just
it's too much of a thermal break. You're just never going to get that wall to perform to the levels that we want it to perform to.
Yeah, and I think it's amazing to me, and it truly is amazing to me that we still have conversations about thermal breaks, and we still see big old beams laying right up against an exterior wall. And they say, well, we're just going to spray foam it back 5 feet and that'll take care of, and you're like, no, you don't understand, right? I mean, it's still those conversations that we have in this day and age of this, and how we can, that's a little bit frustrating of a conversation that I find that we still have on almost every project. And it's what those conversations, like, we can do so much better by just a little bit different staging of how we do things on the construction site, different wall assemblies. It's very interesting. So I'm I'm in the process of designing my house in Glenwood Springs. I'm going to do an ICF foundation. I'm above grade. I've been playing around with walls assemblies. I thought I was going to do an ICF all the way up. And then, just the nature of where to build, the local contractors, double stud wall seems to be kind of the way I'm leading at the moment, because it's not that hard to frame, right? You can use conventional framer is going to know how to put those walls together. It's not any crazier than what they're doing, and you get a good continuous insulation value through it. So I'm back and forth on that. I'm still playing around with that. So I'm asking almost every architect that does either builder or architect, well, what's your favorite wall assembly? And so everybody's like, well, it depends. So some people are like, oh, I love double wall stud because it's simple. And I'm like, all right, well, that's kind of the way I'm leaning, because continuous insulation can be tricky on how to figure out how to put it on there.
Depends on the siding that you want, for sure. Yeah.
Yeah, exactly. Yeah. It all comes down to that siding. So it's a different, just that conversation of, what wall assembly is the right wall assembly? Which one's your favorite? And it's like, well, there's pros and cons of that. Does everybody understand how quickly it could be to, if more people understood when to choose one or the other and not have to go through it. And when they sit down and draw the house, like you say, when you start putting down lines on the drawing, the power of what you're doing, interior volume space, what size do you want the house to be, interior space, how does that affect your wall, and all these other things that play into setbacks, and where we got to put things, and, what's the makeup going to be with that building or that structure when we're all said and done. It has to be thought about as soon as you start putting that pen to paper, because there's a lot, things start growing one way or the other. It's a three-dimensional object. And as soon as you put down a line and you call it a boundary, right, we've got something we're working with, and now it's going to grow from there. And I think that's just,
we always used to draw our exterior walls 6 inches thick. So you're starting off in schematic design and you're drawing walls 6 inches thick. And then you get into construction. You're like, oh, I really want more insulation than that. And then it's hard because all your sizes of rooms and things are set. And if you got, bathrooms 5 feet wide and stairs 3 feet wide, you can't make those any narrower. We realized a while ago, it's like, okay, in schematic design, we do walls 1 foot thick. And that way it's always easier to make the wall a little thinner. You get a little more space inside. Great. Start off with 1 foot thick exterior walls, and you got all sorts of choices then.
See, I think just that right there, right? That should just be like out of the box in Revit or whatever the program is, right? It's already a 1 inch thick wall. See, if that was just a standard, just think of how quickly we could move forward with just not having conversations, because it's already been thought about. It's already laid out that way versus just laying out a 2x6 wall. And that, it seems just so simple, but that's the things even heel, when you get to truss, the heel trusses, why it's just not already a standard that, that needs to be 14 or 16 inches of a heel truss, why we're still dealing with 10-inch heel trusses. It just kills me that we still have those conversations. And, it's just like, why isn't that just
6-inch heel? Remodeling is always hard. Remodeling, we get into 4-inch heel height. Sometimes you got the 2x4 coming in, 2x4 coming down, and the pinches down to 4 inches at the exterior wall. You're like, oh, but yeah, we still get questions about, why do you have such a high heel height on your truss? It's like, really?
Yeah, it's like we shouldn't have those conversations
we
anymore.
Don't want to pinch down the insulation there. Yeah.
Yeah, exactly. It's just still those conversations that we have. And now, you talk about, air barriers and how to put in air barriers, and, how you have to, maybe pre-install some air barrier and roll it up, and it has to sit there until you put up a wall, and then you got to roll it up on that to get that continuous layer, right? That's a little bit of a staging thing. And if we can't even start with just making sure the space of the walls, the building's going to be correct, because we laid it out with 2x6, and they're like, hey, us as energy models, hey, if we went to a 1 foot thick wall, they're like, oh, well, we can't do that. You're like, oh man, right? So I just think that's brilliant. That's brilliant, right? That's just something that you think should already be standard. So I think that's kind of the fight, right? That's kind of the fight that's out there. Is just to say, start all your schematic designs as 1 inch thick wall, then it's never an issue. Yeah, that's great. So I kind of already know where this will go, but if you had extra money on a project, how would you recommend a client use it?
I would start with Windows because that's the I would I would say, hey, if we got a little extra money, let's get those European style windows. Let's get the really high end. Get that down to zero point 0.1 something for your U value on those windows. You won't regret that, and they will last a long time. Next to the mechanical system, I'd say let's make sure we got a really good ERV. Let's just whatever tweaking we can do. Photovoltaics, I think, is another good one. A lot of times we'll plan for photovoltaics on the roof. I mean, we always do that, but then they don't get in there because of cost reasons. And it's like, well, at least a setup for it so they can add the PV whenever they want, or put more PV on, do some ground mounted PV, do something out in the landscape. I mean, there are so many good places to spend money, and it's not on a more expensive granite for your kitchen counter.
Yeah. And I was just getting ready to say it's not finishes typically, right?
You can always change those, and those do get changed. Do something that is going to last for forever or nearly forever. Something that is really going to be something that increases your comfort, that decreases your energy use, and something that maybe is not so sexy, but it really will make a difference.
Yeah, I mean, right. Windows, infrastructure of the building, the bones of the building are kind of like a one-time deal, right? Where countertops, you can replace a countertop in 7 years, and that can be done in all in, somebody coming in, removing the old ones, putting new ones in. It may be 2 days that you're out without a countertop, right? I mean, that's something that can happen that quick. It's not that, I mean, it may, in 2 days is kind of being, I think, generous. Most time it's been a day, somebody could come in and swap out a countertop. So, what advice would you give someone just starting to consider building and or designing a building, or buying an existing building? I think that's the other side of that. I mean, when somebody's looking at a building, whether it be a new design or buying a building, what do you think they should be considering?
I mean, if you're starting to design, or you're thinking you're going to build your own house, it sounds like you're doing some good research. That's great. And I would encourage that. I'd say do some of your own research so you can talk intelligibly to the designers that you hire, architects, engineers, so you can really understand and have some good conversations with them, and not just have to take everything that they say for as gospel, but learn enough about what they're doing so that you can watch over that. So spend a little time on the Building Science Corporation website, www.buildingscience.com. It's a great website that has a lot of very good information, and you might find that sometimes you'll know something new that maybe the designers on the project don't even know yet, and be able to help them along. If you're looking at an existing building, just go in with your eyes wide open. Boy, that's there's do some study of the current systems and how long they're going to last, and what upgrades you're going to need. Because when you're buying an existing building, you're buying somebody else's headaches a lot of times, and that's a great way to save on a lot of construction. But you could, if you're buying problems, that's something you really need to be aware of. And if you're buying a piece of property, look at the orientation. I can't tell you how many people, I wish every client before they buy a piece of property would talk to us and get our blessing of the property first. But usually they go buy the property and then they hire us, and they talk about how they want passive solar and they want all these things, and then you go and you look and they've got this great north facing view, You know, and it's like, oh, why did you buy this property? We want a south facing view. That's or there are access problems. We've had clients buy something. Yeah, and I want my house right up here. And it's like, well, that's great. There's no way to get a driveway to that.
We could do helicopter into that one, gondola.
Yeah. We had that one time where we just said, okay, then your garage is going in the basement. And even though you wanted everything on one floor so you didn't have to walk, we're going to put an elevator in so you can go into your garage, go into the house, go up the elevator, and still have that one floor living. And aging in place is huge. So if you're buying a house, don't buy a house that's built in the 60s or 70s and has all these different levels and steps in between each. You're never going to grow old in that house. There's so much to look at. I mean, there's so many caveats. I would say do some research and hire an architect that you really feel gets who you are and understands your personality and your what's important to you, because that's I'd say the most important key to success in my mind.
Definitely agree. So what's an example of a design mistake or failure that you experienced, and what'd you learn from it?
Failure. Early on, the first school that we designed, I really wanted it to be as sustainable as possible. And this was back in the around the year 2000, early 2000s. And we didn't have heat pump systems then, and they had a big budget. And I talked them into a evaporative cooler for the whole school. Took two giant evaporative coolers sitting up on the roof, and we built these cute little houses around them. It's kind of a farm-looking project, farm school, and totally talked them into it. They didn't want it, and they finally acquiesced and said, "Okay." And I just like celebrated that day that they told me that they were going to go with the evaporative cooler. And because I thought it was, it's a great way to cool. It's a great way to cool my house. Why wouldn't it be great on this school? And years later, going back and visiting the school and talking to them, they said, "Boy, that was the biggest mistake we made." And it just really just kind of crushed my heart. I was like, and I totally forced it on them. The reason is it just didn't fit them. It's very noisy. They have all this air blowing through the school, blowing papers around. Maybe now they don't have as much paper to blow around, but it really, I didn't really think about it from their perspective and understand what they really wanted. And instead I forced my agenda on them. And I think that's a good lesson to learn, that frankly, it's not always about sustainability, because you can come up with a great sustainable system, but if it doesn't work for your client, if it doesn't work for the occupants of the building, then it's not a great sustainable system. And so it's, there are nuances and many things to look at on almost every decision we make. It's overwhelming. That's a great, I think that's a great answer. I mean, it's just definitely back in the day. I mean, that was the technology we had, was pretty much, evaporative cooler, direct, indirect evaporative cooling as well. But still, you still end up with the same kind of issues with those systems that you're moving a lot of air. That's a great answer. All right. So closing questions. What is your favorite building and why? So many favorites. I love Falling Water, Frank Lloyd Wright's residential masterpiece. But no, I'd say I was at this building years ago at the MIT campus. It's a chapel designed by Eero Saarinen. And it's this little round chapel. It sits in the middle of the campus, and it's got a little water reflecting pool around it. And you walk inside, and the sun bounces off the reflecting pool and comes up through these really low arches all the way around the outside edge of the chapel. And it just, the lighting in it and is is just it's a stunning jewel of a building.
Very good. What is your favorite place and why?
That would be a very different answer. My favorite place would be standing on top of just about any mountain, especially our mountains here in Colorado. Preferably not a 14er because you're almost guaranteed to have other people with you there. I like being on the top of a mountain that I got there on my own 2 feet, and maybe have some trials and tribulations getting up there, so you really enjoy it and nobody else around. And I love the feeling, the exhilaration of coming through trees up above tree line, and the whole landscape changes in such a dramatic way. And the lack of life up there, and the starkness, and I love that feeling. So,
very nice.
There's cities I like too, but if you're going to ask my favorite place, that's my answer.
Yeah, I'm with you there. Biggest lesson you learned in the past year about creating better buildings?
Biggest lesson I've learned, I'm actually, we've talked a lot about insulation, but we've had some good projects where we've had good energy modelers on the project, and I've been astounded at how you get to a certain level of insulation and the cost benefit really diminishes. And I've always been a proponent of more is better when it comes to insulation. And when they show you in dollars that that you're up at R30, that's great, or even R25 in a wall, or R30, R35, R40 in a roof, and you start getting above that, you're really starting to throw money away. Use it somewhere else because it's not doing as much good as you think it might. So that was eye-opening for me.
Less thermal breaks, though.
Yes, absolutely.
Less thermal breaks. That's the key, right? There's a lot of diminishing returns with insulation, but you got to watch the thermal breaks. So anyways, so for someone listening and they would like to get a hold of you, how would they go about doing that?
Oh, I think I'm pretty easy to find if you know how to spell my name. Ewers. Search on Peter Ewers, and Ewers Architecture should come up. You can go to our website and email me from there. My email is pretty easy, peter@ewersarchitecture.com, if you know how to spell it.
Yeah, exactly. And say it right.
You don't have to know how to say it in order to get a hold of me.
Yeah, but when you talk,
yeah. Email is a great way to get a hold of me. That's probably my preferred communication.
Well, that's great. And I mean, so I really appreciate you being part of the podcast.
Thank you.
Yeah,
it's really fun.
Yeah, I'm glad you enjoyed it. I think we talked about a lot of stuff, right? And I have a lot of notes here about things that I thought were just really cool. But the one thing that I have written down here that I just cannot, this is like the aha moment for me, is just when you start your schematic design, just start drawing a 1-inch thick wall. It'll
1 foot, 1 foot.
1 foot.
1 foot thick.
I said 1 inch. Yeah. 1 foot thick wall, right?
1 foot thick. Yep.
Just if we can just start with that, it's going to solve so many problems. We can, like you said, we can shrink it down. You can't. It's so hard to go the other way. I just think that's the biggest takeaway for me. I think that's just great that you're as a design. As one of your standards. This is how we start, and I just think let's start big and go down. You can't go wrong with that. That's just that's the biggest thing. So huge for me. Huge for me. It's like mind shifting. Honestly, it really is. It really is. And I also like the story about the logos. Right. I think that was great. I think that
I've told that one a lot. Yeah.
Yeah, that's a great story. So So all right. Well, thank you, Peter. Thank listeners for listening to the podcast. Hope everybody enjoyed the conversation. Always check out our website, dma-eng.com for new episodes. Check out the blog posts that are out there, and really appreciate everybody listening to this podcast. Thanks.